Hello. So today we'll discuss about a particular question of trigonometry and we'll make beautiful use of different chapters of mathematics to solve this particular question of trigonometry. So in total we'll be discussing 3 different methods to solve this question. So the question here is product of r equals 1 to, let's say, 3, and we have tan square r pi by 7. This is the question. Now pi indicates that this value will be equal to, this is equal to tan square. If you put r equals 1, you'll be getting tan square of pi by 7. Then you'll be getting tan square of 2 pi by 7 and tan square of 3 pi by 7. We'll have to find the value of this particular expression. Now we'll discuss 3 methods to solve this question. This is a question of trigonometry, obviously. First method we'll use will be from the chapter quadratic equations. Now the second method that we'll be using will be from the chapter limits, and then the third method that we'll discuss will be from the chapter complex numbers. So first method we'll discuss here. So in the first method, what we'll do is, let's say if I talk about a particular equation, let's say if I write an equation that tan of 7 theta is equal to 0, and if I ask you find let's say the solutions corresponding to this equation. So you will say that tan 7 theta equals 0 will happen only when the argument of this particular function, tan function, is a multiple of pi. So you can say 7 theta should be equal to n pi, where n is an integer. So basically 7 theta has to be an integral multiple of pi, right? So you will say that this particular question will have solutions if 7 theta is equal to n pi, right? So you'll say a particular solution could be if you write theta is equal to n pi by 7, where n is an integer, right? Let's say if you put n equals 0, you'll get theta equals 0, right? If you put n equals 1, you'll get theta equals pi by 7. Then n equals 2 pi by 7. Then we have 3 pi by 7, 4 pi by 7, 5 pi by 7, and then let's say if you put 6, you'll get 6 pi by 7, right? So these values would be there in this particular solution, right? Now if I say, let's say this is a particular solution here, so I can write tan 7 theta, this equals 0, will also imply that if tan 0, theta equals 0 is a solution, I can write tan theta minus 0 or tan 0 will be a corresponding factor, right? Now similarly, I can write here tan theta minus tan of pi by 7 as a factor, because this equals 0 implies this equals 0 as well. Now similarly, I can write tan theta minus tan of 2 pi by 7 is a factor as well. Now similarly, this will go on till I write tan theta minus tan of 6 pi by 7. Now if I write here, let's say if I increase the value of n here, this will become tan of 7 pi by 7. Now 7 pi by 7 is tan pi, which is 0. So this factor will get repeated here, right? So I can write tan 7 theta equals to 0. This will imply this particular, let's say, function is 0 as well, right? Now from trigonometry, we know that the formula for tan of, let's say, 7 theta, or I can write this tan 7 theta as tan of theta plus theta plus theta 7 times theta, right? Now there's a formula for tan of a plus b plus c, or the formula for tan of a1 plus a2 plus a3 and so on, right? The formula is S1 minus S3 plus S5, and then what happens is I can write alternate plus and minus signs. Here I can write 1 minus S2 plus S4 minus S6, right? What are these S1, S2? So S1 is sum of the roots taken one at a time. This is sum of the terms here taken 3 at a time, taken 5 at a time, taken 7 at a time, here taken 2 at a time, 4 at a time, 6 at a time, right? Now, if I write, this is basically tan 7 theta here. So tan 7 theta is equal to this, right? So S1 would mean that these terms being taken one at a time. So I'll have to write tan theta plus tan theta plus tan theta, in total 7C1. We are making use of permutation and combination as well. So out of 7 we have to select 1. So this term will be 7C1 tan theta. Now S3. S3 would mean you have to select 3 terms, right? So if you select 3 terms, tan theta, and tan theta, you'll have to multiply these terms and you will get tan cube theta, right? So 7C1 tan theta minus 7C3. We'll have to select any 3 and then we'll have to multiply these tan theta terms. So you'll get tan cube theta. Similarly, plus 7C5 tan raised to the power 5 theta, and then minus 7C7 tan raised to the power 7 theta upon this term, which is 1 minus S2 plus S4 minus S6. This will mean this is the value of tan of 7 theta, right? Now this is tan 7 theta. So if I write tan 7 theta equals 0, will imply that this particular numerator is 0 as well, right? And here I can see that the maximum power of theta, or the degree of this numerator, is a 7 in terms of tan theta. This is 7. The coefficient of tan raised to the power 7 theta is minus of 7C7. 7C7 is 1. So the coefficient of tan raised to the power 7 theta is minus 1 here. Here if I check the coefficient of tan raised to the power 7 theta, tan theta into tan theta into tan theta, this gets multiplied 7 times. So tan raised to the power 7 theta has the coefficient plus 1. Here it is minus 1. So what we'll do, we'll equate these two terms, but after multiplying with minus 1 here, okay? So this expression would become, so you can see this expression would become, now I have to write this term and negative of this term, right? So I can write here tan theta into tan theta minus tan pi by 7 into tan theta minus tan 6 pi by 7. I'm clubbing these two terms, okay? Now similarly, I can write tan theta minus tan 2 pi by 7 into tan theta minus tan 5 pi by 7. I have clubbed these two terms as well. Similarly, the third pair would be tan theta minus tan 3 pi by 7 and tan theta minus tan 4 pi by 7. So this is the product here. Now this will be equal to negative of 7C1 tan theta minus 7C3 tan cube theta plus 7C5 tan raised to the power 5 theta minus 7C7 tan raised to the power 7 theta, okay? Now looking at this particular term, we know that the value of tan of pi minus theta is equal to tan theta with minus sign here. So tan of pi minus theta is equal to minus of tan theta here, right? This is equal to minus of tan theta. So I can write here tan of 6 pi by 7 as tan of minus pi by 7, right? This is minus of tan pi by 7 here. So that this becomes tan theta plus tan pi by 7. Similarly, I can write tan 5 pi by 7 as minus of tan 2 pi by 7, so that this becomes tan theta plus tan of 2 pi by 7. Similarly, this will become tan theta plus tan of 3 pi by 7, right? If you multiply these two terms, so this particular expression here in the left hand side, this will become tan theta into tan theta minus tan pi by 7 into this will become tan theta plus tan pi by 7. If I multiply these two terms now, this will become a minus b into a plus b, which is also equal to a square minus b square. So this will become tan square theta minus tan square pi by 7. Now the similarly second pair would be tan theta minus tan of 2 pi by 7 into tan theta plus tan of 2 pi by 7. Now similarly, the third pair will become tan theta minus tan 3 pi by 7 into tan theta plus tan of 3 pi by 7. Now similarly, if I multiply these two terms, this will become tan square theta minus tan square 3 pi by 7, right? So left hand side is this one. Right hand side, if I talk about, I'll have to write, see, the coefficient of tan raised to the power 7 theta will become 7c7, right? So this is 7c7 tan raised to the power 7 theta. Now this coefficient is minus of 7c5 tan raised to the power 5 theta. Now similarly, this will become plus of 7c3 tan raised to the power 3 theta, and then plus of, sorry, this will become minus of 7c1 tan theta. Okay, I'll have to equate these two. So this particular expression now will become tan theta into tan square theta minus tan square pi by 7 into tan square theta minus tan square 2 pi by 7 into tan square theta minus tan square of 3 pi by 7. So I'll have to equate these two terms now. So you can see tan theta could be taken common out from here, and if I talk about the roots of this particular equation, if I let's say cancel out tan theta on both sides, right hand side, this left hand side will become tan square theta minus tan square of pi by 7 into tan square theta minus tan square 2 pi by 7 into tan square theta minus tan square of 3 pi by 7 is equal to, what I'm doing is I'm just taking tan theta common out from both the sides, right? So this will become 7c7, this is tan square theta raised to the power 3 minus 7c5 tan square theta raised to the power 2, and then plus 7c3, this will become tan square theta raised to the power 1, and this is just minus 7c1. So if I compare these two, so I can consider this right hand side as an equation in terms of tan square theta. Now the roots are tan square pi by 7, tan square 2 pi by 7, and tan square 3 pi by 7. So these will be the solutions for this particular equation, right? So I can consider this equation as 7c7 tan square theta cube minus minus 7c5 into tan square theta whole square plus 7c3 tan square theta raised to the power 1 and minus 7c1 equals 0, having solutions as tan square pi by 7, first one, then we have tan square 2 pi by 7, and then we have tan square of 3 pi by 7. I can use Vita's rule or sum of, let's say, the coefficient, sum of the roots here. I can write S1, which is sum of the roots taken one at a time, as a negative of this upon this coefficient. So I can write the sum of these three will be equal to, so I can write tan square pi by 7 plus tan square 2 pi by 7 plus tan square of 3 pi by 7. This will become negative of this upon this, which is 7c5 upon 7c7, which is basically 7c5. This value is 1 here, so this will become 7c5 or 7c2. So eventually this sigma or sum of these values will be equal to 7c2. Now if I write product of these values, so product of these values will become tan square pi by 7 into tan square 2 pi by 7 into tan square 3 pi by 7. This will become, I can write here plus, then minus, then plus here, and then minus here, right? So I can write product of these three terms will be equal to negative of this upon plus of this. So it will be equal to 7c1, which is equal to 7 only. So the product of these terms is equal to 7. So what we intended to find was basically the product of these three terms, tan square pi by 7, tan square 2 pi by 7, and tan square 3 pi by 7. What we have done here is we have made use of trigonometric formula here, which is tan of a plus b plus c and so on, and we have used quadratic equations here in order to find this particular answer, the value of this particular expression. Okay, so we have, this was method 1 in which we used quadratic equations. The second method will use limits, which is from calculus. So method 2 I'll discuss now. So in method 2 I can write here tan theta or tan 7 theta is basically equal to S1 minus S3 plus S5 minus S7 upon 1 minus S2 and then plus of S4 minus S6, right? And we have equated this term in terms of that polynomial that we have just discussed. So I can write here tan 7 theta is equal to, now this is equal to tan theta into tan square theta minus tan square pi by 7, tan square theta minus tan square 2 pi by 7. This we have discussed in the earlier method, into tan square theta minus tan square of 3 pi by 7, right? And negative of this was equal to the numerator, right? Upon this upon 1 minus, now 1 minus this S2, S4 and S6, this will have at least degree 2 of tan theta. So it is, we can take tan square theta common from here. So I can write this as 1 minus tan square theta into a polynomial in tan theta. This is polynomial in tan theta, right? Now what I am doing is I am just dividing these two. I am just dividing tan 7 theta and tan theta I am taking on left hand side. So I am writing limit theta tends to 0. These two are equal, so I am just I can equate these two. I can write limit theta tends to 0 tan of 7 theta upon tan theta equals. Now I can write this as negative of limit theta tends to 0. I am making use of calculus limit here. Limit theta tends to 0 tan square theta minus tan square pi by 7 into tan square theta minus tan square 2 pi by 7 into tan square theta minus tan square 3 pi by 7 upon 1 minus tan square theta into a polynomial in terms of tan theta. Now if I write theta equals 0, this would become 0, this is 0, this is 0. So this would mean minus tan square pi by 7 minus tan square 2 pi by 7 minus tan square 3 pi by 7. This will get multiplied with a negative sign. So this eventually this will become positive in the numerator. In denominator what will happen? If I write theta tends to 0, the limit of this will be 0. Eventually denominator will become 1. So numerator is what we intended to find and denominator is 1. So basically right hand side now becomes this is tan square pi by 7 into tan square 2 pi by 7 into tan square 3 pi by 7. And by using limits, we can see that this value becomes limit theta tends to 0. This is tan of 7 theta upon tan 7 theta into, I can write tan theta, and theta here, this is, these two are different limits, and there will be a coefficient of 7 over here, right? I have written 7 theta here, so there will be a coefficient of 7. Now we know that when x tends to 0, tan x by x is 1. So here theta tends to 0, tan 7 theta upon 7 theta is 1. So this limit is 1. Similarly, theta upon tan theta, this limit will also be equal to 1. So eventually 1 into 7. So left hand side becomes 7. So the value of this particular term is again equal to, this is again equal to 7. So this was method 2 in which we used calculus. Now we'll use method 3 in which we'll use complex numbers in order to find the value of this particular term. Okay. Okay. Now we'll discuss method 3. So in method 3, this is method 3 of the same question. Okay. So in method 3, we are, let's say, taking a particular equation which is z raised to the power 7 minus 1 equals 0. So this is the equation z raised to the power 7 minus 1 equals 0, and z is a complex number, right? So what I can do is I can write the factors here of z raised to the power 7 minus 1, right? So if I write the factors, I can write z raised to the power 7 minus 1 equals, one of the roots would be, or let's say one of the factors would be z minus 1. We know this particular equation has 7 complex roots. Let's say the roots lie on a circle having center at origin and radius as 1 unit, right? So z minus 1 would be the first factor. Let's say the second factor would be z minus alpha, where alpha is the 7th root of unity of 1. Now here similarly, I can write z minus alpha square, z minus alpha cube, z minus alpha raised to the power 4, z minus alpha raised to the power 5, z minus alpha raised to the power 6. These are the, let's say, factors. Now I know that let's say one of the roots is alpha here, so alpha satisfies the particular equation. So we know that alpha raised to the power 6 is basically 1 upon alpha. 1 we can write as mod alpha ka square, this is mod alpha whole square. So we can write alpha raised to the power 6 as alpha bar, which is alpha conjugate. Now similarly, I can write alpha raised to the power 5 as alpha square conjugate, alpha raised to the power 4 as alpha cube conjugate. Okay. So I'm assuming that the question being discussed here, the learners or you know the concept of complex numbers, or this is a concept of nth roots of complex number, right? Okay. So these, let's say, concepts we'll use here. So I can write z raised to the power 7 minus 1 upon z minus 1. This as, now what I'm doing is I'm clubbing z minus alpha and z minus alpha raised to the power 6. Now I can write z minus alpha raised to the power 6 as z minus alpha bar. So this becomes z minus alpha into z minus alpha bar. Now similarly, the second bracket would become z minus alpha square and z minus alpha square conjugate. Now third would become z minus alpha cube and z minus alpha cube conjugate, right? If I multiply these two, I'll be getting z square minus 2z, or let's say I can write z square minus z times alpha plus alpha bar, right? Z times alpha plus alpha bar plus alpha alpha bar. So alpha alpha bar would become mod alpha whole square, and mod alpha is basically 1, right? And these terms will also be there. So I'm just manipulating these two, and these you'll understand how these will be manipulated here. So this is equal to z square minus z times. Now what is alpha? Alpha is 7th root of unity. So if I write alpha plus alpha bar, so this alpha would be of the format cos theta plus I sin theta, right? This will be of the format cos theta minus I sin theta. So those sin theta terms or the imaginary terms will get cancelled out. So here we'll be getting 2 times of real part, right? So I can write z square minus 2 times of z, and real part of alpha will be cos pi by 7, 2 pi by 7, and this will become plus 1, right? See, here alpha is basically e raised to the power, I can write alpha as e raised to the power I 2 pi by 7, which is equal to cos 2 pi by 7 plus iota times sin 2 pi by 7, right? So real part of alpha will become cos 2 pi by 7. Now similarly I can write this alpha square's real part will be cos 4 pi by 7, and similarly here you'll get cos 6 pi by 7. So this particular term would become z square minus 2z cos of 4 pi by 7 plus 1, and this is z square minus 2z cos of 6 pi by 7 plus 1. Now this is equal to, if I take this as a GP, I can write this particular term as 1 plus z square plus z cube plus z raised to the power 4, z raised to the power 5 plus z raised to the power 6 in the left hand side. Now this is equal to this particular given expression. So this is an identity. This will be valid for any value of z. So I can put z equals 1 if I like. I can put z equals 0 if I like, or I can put z equals minus 1. If I can even put z equals iota, minus iota, and so on, because this is an identity. So what I'm doing is I'm taking z equals 1, let's say. If you take z equals 1 on the left hand side, put z equals 1. Left hand side there are 7 terms, so this will become 7. Left hand side is 7 is equal to, put z equals 1 here, you will get 1 plus 1. So 2 minus 2 times cos 2 pi by 7, right? So this is basically 2 minus 2 cos 2 pi by 7, right? Now if I take 2 common from here, it will become, or let's say if I write the second term, this will become 2 minus 2 cos 4 pi by 7. And the third term will be 2 minus 2 cos of 6 pi by 7. Now you should understand the manipulation. What is happening here is I can take 2 common from here, 2 from here, and 2 from here. So that I'll be getting 2 raised to the power 3 out. So I'm writing 7 is equal to 2 raised to the power 3 into, I will be left with 1 minus cos theta. So 1 minus cos 2a is 2 sine square a. So 2 from here again, 2 from here, and 2 from here. So again you'll be getting 2 raised to the power 3. So I'm writing 2 raised to the power 3, and this will become sine square of pi by 7 into sine square of 2 pi by 7 into sine square of 3 pi by 7. So basically the product of these sine terms or sine square terms will become 7 upon 2 raised to the power 6, right? Now similarly what I can do is I can put z equals minus 1. Now you know the manipulation what is happening here. I am just writing z equals minus 1 in the same expression here. Left hand side, if you put z equals minus 1, this gets cancelled, this gets cancelled, this gets cancelled. Putting z equals minus 1, this will become plus 1, right? So left hand side becomes plus 1. Right hand side, what will happen is, if you put z equals minus 1, again 1 plus 1, 2, and this is plus 2 times, right? So this I can write as 2 plus 2 times cos 2 pi by 7, right? Into 2 plus 2 cos 4 pi by 7, and I can write 2 plus 2 cos of 6 pi by 7. Now you can see 2 can be taken out from here, 2 can be taken common out from here, 2 can be taken common from here. So 2 cube you'll get, so you can write 1 equals 2 cube, and then 1 plus cos 2a is again 2 cos square a. So 2 from here, 2 from this bracket again, 2 from this bracket again, you'll be getting 2 cube again. And then after this, you'll have cos square pi by 7, cos square 2 pi by 7, and cos square of 3 pi by 7. So we can see that the product of these sine square terms is 7 upon 2 raised to the power 6, and the product of these cos square terms is 1 upon 2 raised to the power 6. So if I divide the first equation by second equation, or let's say if I write 1 by 2 here, first equation divided by the second one, you will get tan square terms in the right hand side, and in the left hand side you'll be left with 7. So I can write 7 equals product of r equals 1, 2, 3, and you'll get the terms of tan square r pi by 7. So this is how we solved this particular question using complex number in method 3. So this was method 3. Before this, we discussed method 2 is this one, which is of limits. This is method 2. And before this, previously we used quadratic equations to solve this particular question. Okay. I hope this question is clear, and keep learning. Thank you all.